Hey there, in this video I am going to discuss growth hormone under the following objectives. Let's first briefly look into the introduction, then let's understand the regulation and then the actions of the growth hormone. Coming to the introduction, growth hormone is secreted by the anterior pituitary gland, and the cells which secrete growth hormone are called as somatotropes. They are also called as acidophils because they take up the acidic dyes. And remember, 30 to 40% of the total cells which are present in the anterior pituitary is constituted by somatotropes. Next, let's understand the regulation. Whenever we write regarding the regulation of the growth hormone, always remember to write the regulation under these three subheadings. First, write regarding the circadian rhythm. Next, write regarding the factors which affect the secretion of the growth hormone. And at last, also write regarding the role of the hypothalamus and the various feedback mechanisms. So first, let's try and understand as to what is this circadian rhythm. As we all know, like few other hormones, the growth hormone also undergoes the circadian rhythm. That means the secretion of growth hormone is not uniform over the period of 24 hours. And also remember that the secretion, let's say I plot the secretion on this axis, that is on the y-axis, and I plot the time here. When we look at the secretion of the growth hormone, the secretion of the growth hormone always happens in burst-like activities like this. It is not constant. So this is what is called as pulsatile secretion of the growth hormone. And once the person sleeps, within 1 to 2 hours of sleep, these bursts of secretions keeps on increasing. That means the maximum secretion of the growth hormone is going to occur during the sleep or 1 to 2 hours after the sleep, more so in NREM stage 2 and stage 4 of the sleep. Okay, this is where the secretion of the growth hormone is going to be maximum. Next, let's understand the factors which affect the secretion and also the role of hypothalamus and the feedback mechanisms. This is a very beautiful table given in Guyton, which tells us the various factors which affect the secretion of the growth hormone. On this side, we have the factors which stimulate the growth hormone secretion, and on this side, we have the factors which inhibit the growth hormone secretion. And one of the most potent factors which stimulates the growth hormone secretion is the decrease in the blood glucose level or hypoglycemia. Okay, any condition which decreases the blood glucose level, like starvation, like fasting, like trauma, like stress, like excitement, or even exercise. All these things are going to cause a reduction in the blood glucose levels, and hence they are going to stimulate the growth hormone secretion. Apart from that, also a decrease in the free fatty acid levels and an increase in the blood amino acid levels like arginine, even protein deficiency, even some hormones like testosterone and estrogen. And as I have already discussed in the circadian rhythm, the deep sleep, particularly stage 2 and stage 4, all of them stimulate the growth hormone secretion. And one more very important hormone which helps in the regulation of the growth hormone secretion, that is growth hormone releasing hormone produced from the hypothalamus. And last but not the least, also mentioned regarding ghrelin. So ghrelin is a hormone which is produced from the stomach, and ghrelin is also a hormone which stimulates the appetite. So ghrelin is basically produced when the stomach is empty, and ghrelin is also going to stimulate the growth hormone secretion. So let's now understand the factors which inhibit the growth hormone secretion. No prizes for guessing. Increase in the blood glucose level. Hyperglycemia is going to inhibit the growth hormone secretion. Increased blood free acid levels whenever the person is aging, whenever there is obesity. And one very important hormone coming from the hypothalamus, which is growth hormone inhibitory hormone, which is also called as somatostatin. Exogenous growth hormone, and very important are these polypeptide compounds which are produced from the various tissues on which the growth hormone acts, and they are called as somatomedins, or they are also called as insulin like growth factor. Very important, these are the one which are going to inhibit the growth hormone secretion. Next, let's understand the role of the hypothalamus and the feedback. Okay, so let's say this is our hypothalamus. Okay, and the hypothalamus is going to secrete two hormones which are helping in the regulation of the secretion of growth hormone. One is called as the growth hormone releasing hormone. Another one is called as the growth hormone inhibiting hormone. Okay, this growth hormone inhibiting hormone is also called as the somatostatin. Now both of them are going to act, okay, on the anterior pituitary gland. They are going to act on the anterior pituitary gland, and growth hormone releasing hormone is going to stimulate the somatotropes, and the somatotropes are going to release the growth hormone, whereas growth hormone inhibiting hormone is going to inhibit the somatotropes in the anterior pituitary, and no growth hormone is produced. Now the growth hormone, which is secreted from the anterior pituitary, it is going to act on various peripheral tissues. Okay, among them the most important is the liver, and the liver or these various peripheral tissues are in turn going to produce one more polypeptide hormone or a group of hormones which are called as somatomedins. These are called as somatomedins because these somatomedins resemble the pro-insulin molecule, and also they are having some actions which resemble insulin. That's why these are also called as insulin-like growth factors. Okay, and one of the most important somatomedin is called as somatomedin C, or it is also called as insulin-like growth factor 1. Okay, now these somatomedins exhibit a very important regulatory mechanism on the secretion of growth hormone. Now how do they do it? They can go and they can directly inhibit the anterior pituitary gland and hence inhibit the secretion of the growth hormone. Second way is they can also act on the hypothalamus, and here they can actually stimulate the secretion of growth hormone inhibitory hormone, or also called as somatostatin. So when somatostatin is produced, it is in turn going to inhibit the anterior pituitary gland and hence inhibit the secretion of the growth hormone. Or the third way how they can act is they can again act on the hypothalamus, and here what they can do is they can inhibit the secretion of growth hormone releasing hormone and hence inhibit the secretion of the growth hormone from the anterior pituitary. So remember, somatomedins are ultimately going to cause inhibition of the secretion of growth hormone. Okay, now the growth hormone itself can inhibit its own secretion by directly inhibiting the anterior pituitary gland. Now there is one more hormone which I had mentioned, which is called as ghrelin. From where it is produced? This is produced basically from the stomach. And what does ghrelin do? Ghrelin is going to act on the anterior pituitary, and it is going to stimulate the anterior pituitary for the secretion of growth hormone. So this feedback mechanisms is what we are supposed to write, and the role of the hypothalamus. Next, let's try and understand the actions of the growth hormone. Now, the actions of the growth hormone are classified into two types. One is called as the direct actions, which are occurring because of the growth hormone, and another one is called as the indirect actions, which are occurring because of insulin-like growth factors, or to be more specific, insulin-like growth factor 1, or also called as somatomedin C. Somatomedin C. So growth hormone is causing the release of these insulin-like growth factors, or somatomedin C, and these are going to mediate the somatic growth actions of the growth hormone. That's why these actions are called as indirect actions. These are called as indirect actions. So first let's try and understand the direct actions. The first action is on the protein metabolism. So what is the action of growth hormone on protein metabolism? It is an anabolic action. That means it is going to increase the protein synthesis. Now how does it do that? By increasing the RNA translation, by increasing the transcription, and also by decreasing the catabolism of proteins. So overall, what is the action of the growth hormone? It is going to stimulate protein synthesis. Okay. Next, let's understand the actions on the fat metabolism. On the fat metabolism, the growth hormone is going to cause lipolysis. Okay, that means the lipid is broken down and lipid is converted into free fatty acids. Now, this is going to increase the concentration of free fatty acids in the blood, and growth hormone also stimulates the conversion of free fatty acids into acetyl CoA. Remember, this acetyl CoA is used as an energy source in cases of hypoglycemia. Now, sometimes when there is prolonged increase in the secretion of growth hormone, as happens in some abnormal conditions, this acetyl CoA can get converted into acetoacetic acid, and hence growth hormone is also said to be ketogenic. That is, it can induce ketosis. So, the underlying point to remember with regards to fat metabolism is that growth hormone is going to cause lipolysis, and it is going to increase the concentration of free fatty acid in the blood. Next, let's understand its action on carbohydrate metabolism. It is going to decrease the glucose utilization by the cells. Now, what do we understand by this is that, now let's say this is the cell, and outside the cell in the plasma we are having glucose. Now, this glucose has to be utilized by the cell. That means the glucose has to enter into the cell, and then glucose will be broken down by the process of glycolysis. Now, this entry of the glucose into the cell is mediated by insulin. So, insulin is the only hormone which is hypoglycemic hormone. So, because of the insulin, the glucose enters into the cell. This is what is called as glucose utilization by the cell. But what the growth hormone is doing is, it is completely blocking this action. So, when this action is blocked, what is going to happen to the concentration of glucose? The concentration of glucose is going to increase. Then it is also going to increase the hepatic glucose output. So, what is going to happen is, there is going to be an increase in the blood glucose level because of the actions of the growth hormone. It is going to cause hyperglycemia. So, whenever there is hyperglycemia, what is going to happen? This hyperglycemia is going to cause an increase in the insulin secretion, isn't it? Okay. So, what did the growth hormone do? Growth hormone increased the blood glucose levels. So, increase in the blood glucose level has caused an increase in the production of insulin. Remember, the growth hormone is not directly causing the increase in the secretion of insulin from the beta cells of the pancreas, but growth hormone is increasing the blood glucose levels. Because of that, there is an increase in the insulin secretion. Now, this increased insulin secretion fails to decrease the blood glucose level. Why? Because growth hormone is decreasing the glucose utilization by the cells. So, now what happens? The insulin secretion keeps on increasing, but there is no decrease in the glucose concentration. So, ultimately what is going to happen is, there is going to be an exhaustion of insulin secretion because by the beta cells of the pancreas. So, ultimately insulin secretion is going to stop, and if the person is having a prolonged increase in the growth hormone production in his body, he is going to land up in frank diabetes mellitus, okay, because of two reasons. One is decreased glucose utilization by the cell, second one is increased insulin secretion, okay. So, the underlying point with respect to carbohydrate metabolism is that the growth hormone is going to increase the blood glucose levels, and it can also precipitate diabetes mellitus. Next, let's understand the actions on the growth. So, when I say growth, it could be on two things. One is the actions are on the bone, another is the actions are on the viscera. So, on the bone, basically the growth hormone is going to act at epiphyseal plates in the developing children in the age group of pre-adolescent age group or pre-adult age group, where they act on the epiphyseal plate. So, what is it that they are going to do at the level of the epiphyseal plate? They are going to increase the protein deposition, which is caused by the chondrocytes. They are also going to increase protein deposition by the osteogenic cells. Okay, then they are going to increase the production of new chondrocytes. This is called as chondrogenesis. Okay, so like this is, let's say this is a bone. Okay, and this is the epiphyseal plate here. Okay, so what they do is there is an increase in the production of chondrocytes. The chondrocyte production is increased. Now once these chondrocytes are deposited here at the level of the epiphyseal plate, they are going to cause the deposition of the cartilage. And what does the growth hormone does? It helps in conversion of this cartilage into bone. So when bone is formed, what is going to happen? This epiphyseal plate is going to be pushed away. That means there is going to be widening of the epiphyseal plate. Okay, this widening of the epiphyseal plate is going to stimulate the linear growth. The growth of the bone is going to increase in that height. That is what is called as the linear growth. Not only that, the growth hormone also stimulates the osteoblasts. So this is how the growth hormone is going to act in the pre-adult age group, and it is going to cause an increase in the height of the person by acting at the level of the epiphyseal plate, by producing new chondrocytes, by deposition of the cartilage, and by conversion of this cartilage into bone, by stimulating osteogenic cells, by stimulating chondrocytes, and also by stimulating the osteoblasts. Not only that, it is also going to cause growth of the viscera, also. So all these actions which I have told you till now are the direct actions. Now let's understand what are the indirect actions. And as we all know, the indirect actions are mediated by the so-called somatomedins, which are produced from the various tissues, to be more specific by the liver. These somatomedins are also called as insulin-like growth factors. So remember, presence of somatomedins is extremely important for the action of growth of the growth hormone. If somatomedins, because of some reasons, are not produced, then the person is going to remain a dwarf. So that means the growth hormone is important. Not only if just growth hormone is present, then the action on growth is not going to occur. Now this growth hormone is going to act on so many tissues, and these tissues are going to produce somatomedin C. Presence of this somatomedin C, the name itself suggests, the somatomedin means this is a compound which is mediating the somatic growth effects of the growth hormone. Okay, so presence of somatomedin C is extremely important for the action of growth. But there are some differences with the actions with respect to the growth hormone as well as the somatomedin. So let's understand those differences. This is a very nice table or a flowchart kind of thing which is given in Gano. So growth hormone, what are its actions? It is going to cause epiphyseal growth. It is going to cause protein synthesis. It is going to cause lipolysis. It is going to decrease the insulin sensitivity, hence it is going to increase the blood glucose level, and it is also going to cause sodium retention. Now growth hormone acts on various tissues and it helps in the production of insulin like growth factor 1. It is also going to cause epiphyseal growth similar to that of growth hormone. It is also going to cause protein synthesis similar to that of growth hormone, but remember that these two actions are entirely opposite to that of growth hormone. One is anti-lipolytic activity. What did the growth hormone do? It caused lipolysis. Okay, and one more is insulin-like activity. What did the growth hormone do? Growth hormone's actions were exactly opposite to that of insulin. It increased the blood glucose level by reducing the glucose utilization by the cells. But what is IGF-1 doing? IGF-1 is having activity like insulin. That's why it is called as insulin-like growth factors. Okay, so remember, these are the indirect actions of the growth hormone which are going to occur via insulin-like growth factor 1, or also called as somatomedins. So let's summarize the entire class. We started with the introduction. We got to know as to from which gland the growth hormone is produced and which cells are producing the growth hormone. And then we understood the regulation, and I told you always write the regulation in 3 parts. First, write regarding the circadian rhythm. Then write the factors which affect the growth hormone secretion, and then write the role of hypothalamus and the various feedback mechanisms. And then in the actions, we understood the direct actions. These were the actions which were there on the protein metabolism, on the lipid metabolism, on the carbohydrate metabolism, and also the actions on the growth. And then we have also understood what is the meaning of indirect actions, which are mediated by IGF-1. So hope so this class was helpful for you. If that's the case, do hit the like button, do share this video and subscribe to my channel. Thanks a lot for listening.